Okay. Okay. Setting up the camera. This is kind of the point in time when I am going to have to check if the stream is working. But I think it is working. So that's good. Yay. Okay, great. I am keeping an eye on the stream. Hi, everyone. We're still setting up a little bit now, but feel free to say hello. If you're joining from, places, feel free to say where you're from. That's always kind of nice to know. And yeah, in a bit, we're going to go ahead and get started with this stream about Ibis, which is an interesting tool. There's a couple of caveats to be aware of, but it does seem to solve an interesting problem. And I will explain some of the aspects of that in this live stream. I've been playing around with it a little bit, and today we're going to do just enough live coding, but especially we're going to go over some of the notes that I made while exploring this tool. I will also switch keyboards for this one. So big keyboard goes there, and then we'll do this here. Right, okay, and it is time. There are 4 people joining in, so that means we can go ahead and get started. So what I'm going to talk about today is this project over here, Ibis. It calls itself the Portable Python DataFrame Library. And the thinking here is that, at this point in time, we definitely have more than one DataFrame library. There's pandas, there's polars, but then maybe it's not always that we want to have a DataFrame library. Maybe there's just sources of data that behave like a table, and we would just like to be able to interact with that. And, there's a bunch of those. So here's a screenshot I made from the Ibis documentation. If you think about like places where there might be data where you might want to do like analysis or maybe even machine learning at some point, then these days you've got BigQuery, you've got ClickHouse, you've got Data Fusion, DuckDB, Druid, Flink, Impala. There's like a huge array of places where you might be able to do some SQL for analytics. But then there are also DataFrame libraries like Dask, Polars, and Pandas. And kind of the dream of Ibis, the dream of this library, is to offer one API, kind of like one language, like one Python object, if you will. And then on your behalf, it is able to generate the code that's needed to communicate with all of these different backends. So kind of the dream there is that if you just took the time to learn this one tool, Ibis, then there's no need to learn about all the different details from all of these other tools over here. That's kind of the hope and the dream. It is good to point out that there are like some subtle nuances at play here that we'll get to in a bit. But one observation you could have in this domain is that there actually are separate kinds of analytics tasks that you might be interested in solving with Ibis. And in particular, there are a couple of libraries that use SQL. So those would be like the databases, Postgres, those kinds of candidates. But then there are also DataFrame libraries that sort of have their own little intricacies as well. And to be specific, both Dask and Polars, they have this sort of expression generating API. The thinking there is that you can write what you want the algorithm to do, and it can kind of do lazy evaluation such that it doesn't run anything until the very end, and it's able to do some optimization there. And then there's, of course, Pandas, which basically just runs the commands as they come in, so there's just naive execution. But you can kind of wonder, like, hey, with a project like Ibis, if it has to support all of this, you can kind of wonder, well, what's the caveat? And we'll dive into those in a bit, but I do hope that you can imagine that if Ibis is interesting to you, you are going to have to accept that it's going to cover a lot of ground, but it might not be able to address every specific use case that you might have. There might be a feature inside of Polars that is really neat and really specific, maybe something with a plugin, and it's not going to be a guarantee that that's going to work through Ibis directly, because the Polars feature that's very specific, well, that might not work on SQLite. And you will still always kind of have that. But perhaps it's easier to explain this a little bit more by showing it to you. Because I do want to mention, like, I do appreciate what Ibis is trying to do here, because it's a very hard problem. And there are these moments when having a sort of single place, a single thing to learn, and then you can deploy in many places, that definitely has merits. So let's just very naively explore Ibis real quick. So here's just a bunch of code. And what I'm doing is I'm telling Ibis, like, hey, import yourself. Then I'm saying, let's run this in interactive mode. That way the visuals are just a little bit nicer. And then I'm able to tell Ibis, as you would normally, to read a CSV file. Okay, this still kind of feels like pandas in a way, right? We're just reading a CSV file, and we get some sort of type out that's a table. And I can render that, and then, I get a table that kind of looks like this. I can scroll a little bit to the right-hand side over here. This is a big table that I'm playing with. Oh, fun fact. One thing about this dataset, I went to Kaggle, and I found the Steam video game dataset, which is the dataset that I'll be using, which has all sorts of data about video games that have been released on the Steam game store. So I can check the release date, I know the developer, etc. I'm not going to go fully into this dataset in this video, but it's a pretty fun dataset to play with. But anyway, it seems that I've got this object that I could go ahead and play with, which is nice. One thing I could do is as a sort of first demo, is I can do kind of a aggregation. So that would be, let's say, the group by that you might normally want to do. And this should feel like very familiar if you're used to pandas. But there's like a subtle difference. So notice that I'm referring to a table over here. Then I can call the group by method. And then I can refer to a column that I want to group over by, again, referring to the table, and then referring to a column name, which is a property on that object. I think I could also do this. Just refer to the column name as a string. But what's kind of interesting here is that you are also able to generate these expressions by keeping in mind what table had the original column. And for a group by, that's not going to matter too much, but you can imagine later if we're going to do joins as well, then sometimes you want to be very specific and say, well, I want to join this table on this column and this other table on that other column. And by having a syntax that allows you to sort of select columns this way, you're actually able to be a little bit more explicit, which is, still kind of nice. But the main thing for now, at least, is that hopefully you can look at this and you can kind of go, well, this still kind of looks like pandas in a way. It's just a different backend, it seems, but it still feels like it's using pandas. So, I can run this a bunch of times, and you do notice that the order is just a little bit different. But let's see what happens if I were to do this in pandas now. So I'm going to basically do the same operation, but like in pandas. Then one thing we can immediately see, which is interesting, is that if I just use the naive way that Ibis likes to do it, so I'm not going to do anything specific, I'm just going to say, hey, Ibis, read a CSV and do a group by, then that takes about a millisecond. But if I were to do that in polars on the same data set, it would definitely take like way more. And you can kind of wonder, well, why is that? The short story in this case, and I could be wrong, but I believe that when you start Ibis this way, it needs to pick a default backend. And there are many to pick from, right? Like we had this chart in the beginning over here. There's lots of backends that it could pick. But the default that Ibis uses is this thing called DuckDB. DuckDB is very likable. It's something that can just, I think you can even run it as a binary. But DuckDB is kind of this more recent analytical database that's pretty easy to install. It doesn't require a Docker container. And for a bunch of reasons, it's also quite fast. But for a bunch of reasons, this is now the default in Ibis. And that's also why if you're not really paying attention, you're just using the API as is, it is actually running DuckDB under the hood, which also means that this expression that you see over here is actually turning this Python code into SQL first. That SQL code is then being passed on to DuckDB, but the experience for you as a user is that you're still just interacting with Python objects. Like even if you don't know anything about SQL, you can still work with this API. And something about that I do think is kind of appealing. I'm not the biggest fan of SQL myself. And the fact that you can not worry about SQL and just use Ibis to generate SQL on your behalf is definitely like a nice feature. Another small detail about that, by the way, is that the SQL dialects between these packages or between these backends are also usually just subtly different. There might be some functions in BigQuery that DuckDB also support, but they might have like a slightly different function name. And this is also something that Ibis handles for you. So Ibis has the notion of a backend, and they make sure that their backend integrates well. But you also don't have to worry about the implementation details or the precise function names or SQL dialects, so to say. That's also handled for you. So that's also a pretty sweet thing or feature, I would say. So, okay, we have the multiple backend thing. We've got the fact that it's also, from the get-go, just a little bit faster than pandas. But what I'm doing right now is kind of a naive way of using Ibis. Like, I'm really saying, let's not worry about anything. Let's just have Ibis read a CSV file. We can also be a little bit more formal and a little bit more explicit, which I thought was actually kind of nice and likable. Oh, but before we get to that, there's actually a few differences I should point out as well. So one thing that Ibis allows you to do is it allows you to have a look at the schema. So this is a table, right? And a table has column names, but each column also definitely has a type that's attached. And that can be very relevant depending on what you're going to be doing. Like whether or not something is a string or an integer or a categorical or something nested or a date, let's say, that's not necessarily obvious. And if you're interested in having a look at that, you can call schema on a table to actually get the type information for each column. If I put my scikit-learn hat on just for a moment, and if I'm interested in maybe featureizing, right? Like I'm interested in taking a schema like this and seeing if I can do something clever, then one thing that I do think is very nice is that it is able to distinguish a date from a string. Because there's stuff I might want to do in terms of machine learning features that for dates would definitely be different than for text in general. And again, like DuckDB is clever. It can do a little bit of inference to figure out which columns might be dates. And that is something that pandas doesn't do from the get-go. Or not as well, I should say. I think it does have some support for it. Like you can designate which columns are dates, etc. But in this particular case, if I just do it very naively, just read CSV on both sides, I do seem to see here that the release date in the schema for DuckDB actually shows me a proper date. And in pandas over here, it shows me a object, which refers to a string. So that's also kind of a nice to have, I think. The fact that we do have a somewhat more elaborate schema at our disposal in a way, and we get some of this stuff for free without even thinking about it, that is definitely kind of nice. I think there's also some other support for, like, we can see here this is an int64. There's other types in here as well. But anyway, this is like a little detail that I did notice that I also did appreciate. Like if I want to have an input for a machine learning model, dates are definitely like a thing I want to have separate from strings. And that's something over here that I would have to do more consciously. Anyway, all that stuff is nice and well and good. But what I wanted to also mention is that maybe we can be a bit less naive and be a bit more formal. Because what you can do is you can say, Ibis, read a CSV file, but you can also be very explicit about which backend you're interested in using. So you can say, Ibis, polars, let's go ahead and connect to polars. Then you've got this polars connection. And then you can tell the polars connection to read in a CSV file. From there, you can read a schema. We can write queries and stuff. That's also things that we can do. But the main thing that I thought was interesting here is that we can also be just explicit about which backend we use. Wouter has made a good comment actually about this. And you're right. So I said object over here. Typically that refers to a string, but Wouter made a good comment. It doesn't have to be a string. In general, it can be a generic object, which is true. Inside pandas also supports like all sorts of objects that are not necessarily strings. Most of the time I've noticed this is a string, but it doesn't necessarily have to be. That's a good observation. And Ibis, I think, is actually more strict here as well. Like in pandas, because you can have a list of whatever Python object in your data frame, like that's something that Ibis doesn't necessarily support. It's also like a difference we'll see in a bit. But anyway, back to this. I do hope it's clear that, I'm also able to read this with polars, and then we also see that the schema is just a little bit different. But yeah, we're still able to read the data set in. And if I'm a bit more explicit and I say, hey, let's have DuckDB make a connection. So we have a connection to DuckDB. I'm saying, here's my local file. DuckDB needs that. Then DuckDB can read a CSV file. And again, I can check the schema. Again, I can see that because we're using DuckDB, that there's a notion of a date here. But the thing that's kind of nice here is that I'm able to say, look, here's a proper connection to a backend. And that's just a little bit more formal. Usually that's like a database, could also be something else, but in the case of this being a database, the nice thing is that you can also then say, okay, that database has tables, and I want to grab that one table from that database. And doing that directly with the backend is just kind of a nice thing sometimes. So that's something I've noticed, like this is actually a nice API for that. But one thing that you can also see here is that I'm able to make all these different connections. So I've got a connection to pandas here, and I've got a table that's referring to a pandas table. I've got a connection to DuckDB here, and I've got a DuckDB table here. And I've also got a polars connection, and I could also make a polars table if I want to. There we go. If I were just to have a look at this polars table, it's going to render the table. But if I just have a look at the type information here, then you do see that we're actually interacting with something that's not necessarily polar specific. We are still talking to Ibis as our user interface, so to say. But in the back of our minds, we should remember that this table is actually using the polars backend. Like there's a subtle difference there. But this is kind of one of those things where you want to talk to a UI, like the SDK of Ibis, and you don't want to necessarily concern yourself too much with the backend. So we are talking to a table, but the backend is polars if I were to use this variable. If I were to use this variable, I would again be talking to a table object, but the backend would be DuckDB. So there's like a difference, but also like a huge similarity in terms of the API. So, okay, these are all like schemas. All that stuff is, I suppose, fine. But one thing we can now also do is just write some code. And the way I like to write DataFrame code, and that's something we'll see that this library actually supports, is you're able to say, well, let's make a function that's just kind of interesting. So in this case, I have a function called aggregate. It's not really doing something that's that specific, but I'm saying let's group by the developer. That's a column that we've got. And let's just count how many games each developer made. So the table has a group by method. That method returns me a table reference that's grouped. And then I'm able to do .aggregate, which is very similar to what you would do in pandas. You would call .ag. And the way that these expressions kind of work is you're able to say, well, I want to count rows on the table, and then I want, then I've got like a count column, but the column has no name yet. And you can attach that similar to how you would do that in polars with the alias, so to say. Okay, so then I've got this function here, and that's great. And I can use that function and give an Ibis table as input. So far, so good. Like I can do that with my pandas data frame, with my pandas table, and it works fine. The thing that's really cool here is the fact that this function, even though it just does a group by, but this function is exactly the same if I give it a pandas table compared to if I give it a DuckDB table. Like the speed might be like slightly different. There's stuff under the hood that's maybe happening. But as far as you are concerned as a user, the API is exactly the same. So if, for example, you have some sort of analysis that you're running locally and you've got like a subset of the data, then you can use a pandas backend to write a query. And then if you think, hey, the query is good now, let's now run it on the heavy backend, like bigquery or postgres or whatever. then you can reuse the exact same code. There's no need to translate your pandas code into something like SQL. You can just reuse this function. And I think that, in a nutshell, is the cool thing that Ibis provides. There's, in the end, one pretty likable way of defining the query that you want to run, and that can just run on many different backends. And especially if you're like a developer where you've got a subset and then you want to translate it to the big thing, the fact that that's the same code can be a big productivity boost. Another thing that I think is kind of cool here as well, if I just think of like the use case for Ibis, and I think that's, they don't market it for this purpose, but I can see myself using it for that, is testing. So imagine that we've, I might want to draw that actually. So imagine that I work for like a big company. Let me just get the drawing equipment set up. So imagine that I work for like a big company, right? And the big company has a big BigQuery table. So BQ, that's the BigQuery table. And once in a while, I want a analytics query to run. So that's some sort of batch job. So either cron or something like Airflow is going to be running, right? And that has a bit of a script. And that's going to be communicating against that BigQuery table. I mean, that's great. But if this were SQL, right? If that cron job was a SQL job, how are you going to write unit tests against that? Like, that would be slightly tricky because what you could theoretically do is you could get like a local SQL engine to run the SQL query. You could give it a CSV file and you can kind of see, well, maybe the output is the same. But BigQuery is a proprietary tool. I don't know if there's a testing library for it that you can download. And this is where Ibis can kind of shine as well. So what Ibis can do is you can just write your Ibis code into, I don't know, like an aggregation function like this. So you've got your Ibis function, right? And then on your behalf, that function can, generate the SQL that's needed for BigQuery. But you can also write against pandas using the same function, and then you can write a unit test for that function. And that, I think, is like a super nice feature, actually. The fact that Ibis allows you to unit test your cron jobs a bit better, even if you're using something like BigQuery, that to me seemed like a very big feature. I don't know if this is something people actually use, but this was the impression I had while playing with this, that, hey, the fact that even if my company uses BigQuery, I'm able to write proper unit tests because this function can be applied in different places. That's super sweet. It's way easier to write a unit test for some pandas code than it is to write a unit test for general SQL. So when I was exploring this, I did realize, like, yeah, this is a this is actually like not a small feature at all. So if this is a problem that you're facing, like, this could actually be an interesting use case to introduce something like Ibis. I'm curious if people have had the same hardship as I've had, let me know. But I did feel like, hey, yeah, this feels somewhat underappreciated. I should at least mention it. There's also another thing that I thought was just kind of a cool thing to just observe. So, like, in reality, right, it's probably going to be not the case that you're going to write like an aggregate function like this per se. Instead, what you might have is a little bit more, I've got a function that can sessionize. So a table goes in, I'm just going to return table just for illustrative purposes. But let's say that there's some logic here that can sessionize some logs or something like that. And then I've got another function here that's remove bots. That's the usual example that I've got. And then I've got another function here, perform analysis. Okay, so these are just here for illustrative purposes. Like, one thing you could do is you could then say, I want to run all this code. So you could do something like perform analysis, then remove the bots, and then sessionize, right? And let's have the pandas table go in here. Okay, so this code would run. There's no logic in these functions, but let's say there was logic. Code like this would run. But I find this incredibly hard to read. And that's because I'm reading from the inside to the outside to appreciate the order of things that are happening. And this would get even worse if, I don't know, there's like a parameter that needs to go in there, and there's another parameter that needs to go in there. Like, this is just kind of hard and nested code to read. Lucky for us, though, there's a, if I recall correctly, there's a pipe function that you can also use on these Ibis tables. And I can also say, hey, let's just take this data frame and pass that as the first argument to the sessionize function. So effectively what that means is that sessionize, like these two things, this line of code where I'm piping the table into a sessionize function, or if I'm using a sessionize function on pandas, both of these two lines of code are equivalent. And the really, really cool thing about that is that this allows me to write a proper pipeline. So I can say, I can write down my code something like this, right? This is nice and readable. I can read this as I have this table, then I sessionize it, then I remove the bots, and then I perform analysis. So like this is, the fact that this works in Ibis is super cool because I kind of get to split up my concerns a bit. But moreover, because I've now got these nice functions, I'm, again, able to write proper unit tests for this. Because that also is a lot easier if you're dealing with a like a pipeline properly. And again, it felt like this feature was underappreciated on their docs, but to me, this is a really big one. The fact that I can easily write unit tests and the fact that, you know, the pipeline still remains intact, that's exactly what I typically like to see. So again, I'm mentioning this because it felt like this might be an underappreciated feature, but so far, you know, I've also not said anything too crazy. Like some of the things I've shown you are also stuff you can find on the docs, but the fact that I can definitely split up my analysis in these functions, that's definitely great. That's a feature I did want to mention. Another thing that I think is actually pretty cool too, and this won't work for everything, but like in this case, right? I'm calling my aggregate function on this duckdb table. Under the hood, what's happening here, right? Like I've got my Python code. This Python code is referring to duckdb. So that means that all these Ibis expressions are going to be turned into SQL first, and then that SQL is going to be passed to duckdb, and then that is going to give me my result. But in order to communicate with SQL databases, at some point, Ibis has to do this SQL translation on our behalf. And kind of a cool thing about Ibis is that you can also actually inspect that SQL code if you want to. So in this case, right, I've got my aggregation function. This gives me, if I were to just pass this into a cell like this, you know, I would get a table back. So you have to remember the type of this thing is still a table. But I am able to see the first few rows because I'm running this in interactive mode. But if I don't care about the table just yet and I just want to get the SQL, Ibis has this toSQL function where I can pass this table object that has all the expressions in it. And okay, I have to be a little bit careful here because I'm reading in the CSV. It's not something that's actually in memory. So this from name is a bit weird, but if we just ignore that for a bit, hey, pretty cool. We get SQL out. And this is a fairly simple statement. If this were a little bit more elaborate, the fact that we can generate SQL for analytical purposes, that's actually kind of nice too. Like if we ever have a policy where we really need to have SQL and that's the only thing we can actually run against our database, even then Ibis can kind of help you. And Ibis can also do it the other way around, which I thought was kind of cute too. So if I were to say, hey, this table, let's give that a proper name, so TBL, then when I do that, I can suddenly write a SQL statement that refers to that table name. And lo and behold, I am able to tell DuckDB, here's the name of a table. Here's a SQL statement that's referring to that table. And then you're also able to just go ahead and run this. So that's also just kind of cool and kind of nice, I think. The one thing that I do think is a limit here is I also had this pandas table, if I'm not mistaken. And I could be wrong, but I think this will break. Yeah, so this will break because pandas, the backend, doesn't use SQL. And I think the error message is probably... Yeah, exactly. So the error message, I guess, could be better. But I would also expect this to fail. Because pandas doesn't have a SQL layer under the hood, it also cannot use SQL to run a query. So this makes sense to me. But I would imagine that as long as the SQL statement that you've got here uses the right SQL dialect, all the SQL backends should support something like this. Which again, kind of a nice feature, especially when you combine that with this. I'm able to have my Python code generate SQL for me. And stuff like this is, kind of nice. It's a pretty solid feature. This will be a good time to maybe ask questions if you have them. But this is basically stuff I tried to get like a pretty solid first impression just by having a look at the docs, and my first impression is pretty good. What I do want to do though is maybe also talk about some of the caveats, because I do think those are good to understand as well. But just to check if there's any questions on this. I think we're good. All right. Then we're going to move down a bit. So there are things that you simply cannot do inside of Ibis that I do think are good to sort of be aware of. Partially because of that SQL thing I mentioned before. It should also probably not be a huge surprise that joins don't work between two different backends. So let's say I've got a table from DuckDB over here, and I would like to join that with the same table from pandas. Then in terms of there are two tables, can I join those columns together? Well, in one line of thinking, you might think, well, they're both tables, so why wouldn't that be possible? But this is the thing with Ibis, you cannot just combine different backends. It's something that's just not allowed. And also if you look at the error message here, if I were to write this query where I'm trying to join a DuckDB table with a pandas table, then it's complaining that there are multiple backends found in this expression. So that's just something we're going to have to slightly accept. It's just not possible. So, okay, let's just run this error live, right? So this is definitely the error we get, and multiple backends are found here, so we can't do that. What we could do, though, and that's the example below. Scroll down a bit. Maybe I can also scroll up here. If I were to replace all the pandas stuff here with the aforementioned DuckDB table, then the join just works fine. And it's a bit of a silly join, but the main demo that I wanted to show you here is that you cannot just go ahead and combine different backends. Like, that's something that's just not allowed. One thing that is kind of, I suppose, cool to see here is that you do definitely see that if I want to do a join, this is one of those moments where it's kind of nice that I'm able to refer to a table and then a column instead of just having strings at my disposal here. But yeah, this is still a likable API. Just remember, if you're going to use a backend, all your queries should stick to that one backend. That's sort of the name of the game here. Then one thing I've also noticed is that you might come across what I will call interesting bugs. So what you can sometimes also do is you can have a table inside of Ibis, and then you want to maybe turn that into a pandas data frame. The use case for this is usually plotting. Like, you've done a lot of analysis, and at some point you want to return this maybe smaller data set into pandas, because pandas is convenient for plotting libraries. Like, a lot of plotting libraries integrate with it properly. So I figured, let's call this toPandas method on this table over here and see what we get. And then at some point it gave me a big red error. And it was saying here that there was an unexpected value for the date type. It's saying that I have this date time object with D. I suppose that's referring to dates. And it's saying that it should be in a different format instead. So what is happening here? Well, there is this date column that I mentioned earlier. That thing is in here. And okay, that's a date column that under the hood, there would be an integer, the way you would represent that. But it seems that the version of pandas that I've got right now is expecting not to have a date timestamp per day as an integer, but to have something more in the seconds or milliseconds range. Being the good person that I am, I reached out on the Ibis documentation, or like the GitHub repo, and I reported this bug. And this is something that should already be fixed in the next release. So that was definitely good news. But this is also kind of one of the things that sort of shows you how hard the problem can be that Ibis tries to solve. Like, if you want to be able to translate a table to pandas, but upstream pandas makes a change, Ibis is going to have to play catch up a little bit. That's not Ibis's fault, it's just that it tries to be the integration library between lots of different other approaches. And that means that if another database or if another backend is changing a few things, that Ibis needs to figure out a way to keep up. And that's a hard problem. Again, in this particular case, though, this issue will be fixed in the next release, so I wouldn't worry too much about it. I think if you install the main branch right now, you'd already not have this issue. But what I can also do instead is if I were to aggregate that docdb table, then I would have a table that doesn't have the date column in it anymore. That I can just turn into pandas just fine. Another way of going about it is to just sort of not worry about that date column. That's also something you could go ahead and do. But do remember, like this turning a Ibis table into a pandas table, there are lots of use cases for that, especially if you want to go and do some plotting, let's say. So there's definitely a good use case for that. I have already mentioned the pipe thing, so that also totally works, which is super sweet. Oh yeah, and this is also an interesting one. I've also found like another thing that I think, and I will gladly be corrected about this, but as I was exploring the API this morning, I also think I found one thing that Ibis probably won't be able to do. And it's a bit of an edge case, but it is an edge case that you might encounter. Oh, Wouter is saying that there's also native integrations now with visualization libraries. So I was wondering about that, because I was looking at Altair plus Ibis, and when I have a look at the example that is on the docs page, this is the Ibis table, and there's group by stuff happening here, and that's fine, but there is this 2 pandas at the end over here, at least on the documentation page. So, I could be wrong, but it is my impression that you will have to do this conversion to pandas in order to get this to work. In the case of Altair, I think they support polars now, so if you translate it to polars, it's also probably fine. But you do need this one extra step at the end here before you pass it on to the visualization library. Yeah, or at least that was my impression when I read this. Like, this 2 pandas thing over here does seem like a required step. If I'm wrong, do tell me, but I think this 2 pandas stuff is no way around it at the moment. And it also kind of makes sense, because Altair only accepts DataFrame libraries. They accept polars or pandas. Those are the only 2 options that they accept at the moment. So it also, like, it feels fine that you have to make that translation step before you do the plot, actually. Because Altair has no notion of SQL, so I'd be somewhat surprised if it was able to generate the SQL needed to do some of its underlying magic. But yeah, okay, it seems that I'm right. Okay, good question though, Wouter. Like, I do appreciate those comments. Going back now though, like the one thing I want to talk about in terms of like, I think there's a thing that you can't do in Ibis. So Ibis has an API, and kind of like pandas, you've got like you can do. I think in pandas you would do something like assign to add like a new column. In polars you would call that with columns. And what you will notice when you're exploring this API is that different verbs, so to say, they have like Ibis has a different word maybe than pandas, but the ideas are still pretty much the same. Like, you have a method that can add a column, you have a method that can remove a column, you have a method that can filter data, etc. Now, the way that you add a column is with this mutate method. So I'm able to say foo equals 1, for example, and then I can get this column that's of type integer 8. And, you know, this is pretty interesting and useful. And what I can also do is I can say, well, let's refer to the DuckDB table. Let's get the app ID. Let's add 1 to that, I think. Table has no... Oh, wait. Remove the underscore. Right, so this will also work. Like, I can have a column expression in here. But what I can also do is I can add, like, a single value in there. This is what mutate does. Mutate allows you to add a column. But this is sometimes not enough. So what I thought I would do as, like, a thought experiment was, like, okay, this DuckDB, this table, I should say, has 27,000 rows or so. And then one thing I was wondering, like, okay, I'm used to pandas and polars, and and there are these things that, at least in pandas, that you can do, where you can have like a list of items that go in here, right? And if you do this in pandas, the first item of the first list would be the first value in the column. The second item would be the second, and you're basically able to, or what I was thinking at least, if this was pandas. If I was giving this mutate function a list, then part of me would expect this list to kind of be attached as a column. Like the first item of the list, 1, 2, 3, that would kind of correspond with the row numbers. That's kind of what I was expecting when I was writing this code. That's not what's happening at all, though. And let's see if I can get both. The screen's a bit too small. But like, if I were to write this, right, then because DuckDB supports nested data structures as well, like a lot of these backends do, the way that this actually is interpreted is not that this is supposed to be a column list and lots of different values. No, it's taking this entire list and it's copying it in every single slot that it's got over here. And it's not unreasonable, actually, that it does this. If I think back about, like, oh, it needs to be able to translate this into SQL, then I do understand, like, oh, right, in SQL you can add, like, a literal, and that fills the entire column. There's stuff to like there. And, okay, and even when I turn it into a NumPy array, right, it's still the same type, but the fact that it's a NumPy array or a list also doesn't matter. There's no type matching there. So even though I do think this is same behavior, it does make me feel that there's this one thing that is hard to do, and that is, what if I've got, like, predictions from a machine learning model that I would like to attach? Like a proper, like, there is this point in time when I'm doing analysis through Ibis, and then maybe I get a data frame out that I'm going to give to scikit-learn, let's say, right? That's certainly a use case that I've got in mind. Well, then scikit-learn will give me predictions, and one thing I was wondering is, what's the easiest path to get that back into an Ibis table? And I was kind of hoping that maybe doing something like this would be the way to go. And again, I will gladly be proven wrong. It could be that I'm wrong here. But my impression is that this is actually something that Ibis doesn't natively support. If you look at the documentation of this mutate function, it does kind of assume that you're using existing columns in order to construct new ones. And if you're using pandas, you're not going to notice that because it's just assuming a naive Python API and it's not doing anything with expressions. But you can imagine, hopefully, that this is a bit less obvious if you're dealing with SQL and expression APIs, etc. So my impression right now is that the thing that Ibis is designed for is analytical tasks, where we just have a bunch of data in a database and we need to wrangle that and get that out somehow. That is something that Ibis is very well suited for. But to update tables with scikit-learn predictions, that's something that, again, I might be missing something, but that was a bit hard. And I'll gladly be told otherwise. But it did feel like that was still something that Ibis doesn't necessarily support natively, which could be kind of fair enough. Like if the use case is to be analytical, like that's the area that Ibis really tries to cover, and it does that quite well. And then it's also totally fine. But like that was the one thing where I did think, like, oh yeah, this is where I'm hitting my head. This might be kind of at the edge case of where Ibis can be used comfortably. So yeah, definitely a lot to like. Ibis has like a huge surface area that it's trying to cover.
It comes with an API that has lots of things that are likable, I would say. I definitely enjoy seeing mutate. I think that's the right name for the verb. I'm an R user as well, so like that was definitely cool to see. But yeah, you should remember that the surface area to cover here is like super big, and the problem that Ibis tries to solve is also like pretty hard, especially because you've got all these competing standards and different implementations. But you know, it only took me a couple of hours to sort of whip this notebook together. It wasn't like a whole day of work. It was like 1 or 2 hours. So the fact that I was able to get this working quickly, you know, there's some stuff to like here. I do think it's a library that deserves some recognition. I guess like a few other like small things that are just good to observe, because we are not necessarily running out of time, but it will be good to wrap up soon. There are also helpers inside of Ibis. So, for example, there are these things called selectors that help you select columns quicker. So one thing that you could do is you could say, hey Ibis, select the following columns. And if you don't feel like writing all the names down, but you want to select all the numerical things, then you can just say, hey, selector, grab me all the numeric columns. And that's something it can totally do. And again, this works on all the different backends. And, you know, it's a nice little util there. That's definitely appreciated. And then there's also like other stuff that you can do. Like you can import this underscore if you would like. And what that underscore allows you to do is instead of having to type t underscore duck here everywhere, the underscore can also be kind of used to indicate that. What's the? Oh, did I make a typo somewhere? I would have assumed that this is fine. Tduck doesn't have developer? Huh, okay, I need to look into that, but I'm wondering what's happening here, though. So this runs fine. All right. And now it does run fine. Okay, I'm not exactly sure what went wrong there. But in terms of syntactic sugar, like before I showed that you can use a column name. Sorry, before I showed you can use a table name and then dot and then a column name. If you don't want to do that, there's also this underscore that you can import from the library. That's kind of a nice little syntactic sugar. And there's also these things like, you know, you can sort the data set, and then Ibis also has a nice little method to sort of tell you that you want to have this column, but you want to sort that in a descending manner. You know, all that stuff in there is good. If you go to the documentation, you will also notice that there are these helper methods. So one thing I can do is I can say, let's grab the categories column in this data set. So there's a categories column. There you go. So there are lots of different like things you can look for, but suppose you're interested in the games that have the Valve anti-cheat feature enabled, then this is a string column, and a string column has access to a contains method. There are lots of these methods that are available, and when you're working with strings in pandas, you would typically have like your column, and then you would type .str, and then you would have like lots and lots of methods that are at your disposal. Ibis also has lots and lots of methods at your disposal. Sometimes not every method will apply to every single backend out there. You got to be a little bit careful, but the coverage seems pretty good so far. Like I've not been able to break it. And if you're on the documentation page, if you're interested in that, you can, I think, go to the table expressions over here. Yeah, so like if you go to the documentation, then you see all the different verbs that you've got on the tables. But if you want to check out all the string expressions, you know, I was just using contains, but there's lots of these expressions that you could go ahead and use. So if you're used to pandas, you know, probably your string stuff from pandas will map on pretty well here. The name will probably be just a little bit different, but it's still a fair game, and it's still all pretty good. Like I was, you know, pleasantly surprised with Ibis. I think there's definitely like stuff to like here. It's also, I want to acknowledge, a super hard problem. It's a lot of catch up you got to play. The only real sort of general thing that I couldn't figure out was what's the easiest way to get scikit-learn predictions as a column in a table like this. Like that's the one thing that I do think is like a pretty honest caveat to maybe think about. Like, again, it could be the case that I've not figured out how to do that in Ibis, but if that's a missing feature, that's like something to consider. But everything else does seem fairly likable, and especially if you find yourself in this situation where, oh, I've got a BigQuery table and I want to have SQL, but I also want to have unit tests for that. I mean, just for that use case, I think Ibis is already like a pretty good slam dunk, if I'm honest. So yeah, hopefully this was useful. I am eager to explore Ibis some more, mainly because I think there might be some nice scikit-learny integration-y things that I should at least consider. So like that's something that's in my mind. No promises there, but I do think that there's stuff to like here, so I'll definitely keep that in mind. I will also be online now for like a few more minutes because I think this was everything I wanted to say. If there's questions, though, do tell me right now, and I'll gladly answer them. Ibis is pretty cool, is the main conclusion I've got. Cool. Okay, I do see some questions come in. It will be nice to serve SQL endpoints with DuckDB for some team members and the Ibis interface for others. That's actually a nice comment, actually. So the suggestion here is that depending on how you want to set up data in your organization, to sort of talk in enterprise speak a bit, but like you can imagine that you've got like a central thing where Ibis can just run commands for you, and then you might say, well, I've got some analysts and I want them to write SQL, and that's going to be handled through Ibis, and there's this other group of people that are going to write Python. I mean, that's a use case. One thing I wonder, though, is let's say that you've got Ibis and you're interested in that because of BigQuery, let's say. Technically, nothing is stopping you from having your analysts just write SQL against BigQuery directly, and maybe just keep the Python people happy by using Ibis to communicate to BigQuery. If you have half the team that's already well versed in SQL, then maybe they can just talk to BigQuery directly. Maybe there's a use case where you've got BigQuery and I don't know some sort of Postgres database as well, and then Ibis is kind of nice because you don't have to worry about SQL variants anymore. But I don't know that many companies who have like usually a company makes a bet on like one technology and tries to stick with it. So I don't, but yeah, it depends on the company. The main thing I think is just kind of nice is I'm a person who doesn't like writing SQL per se, and the fact that I have to do less of that from Python, pretty cool. Like that's the main thing I would be happy with. I see a question come in about like Ibis and laziness, and there's actually some interesting news on that front. So let's have a look here. So getting started, right? Okay, installation, sure. I noticed that there was some support for Apache Flink as well. And Apache Flink is a streaming technology. So when we think about laziness, if it's fully streaming, something interesting about that. And from the looks of it, I've not given it a try, but it seems like you're going to be making a connection, just like I showed you before with like a DuckDB connection. And from there on, it should be relatively the same. So it does depend on the backend a bit. Like some backends have this lazy support more central than other places. But the fact that it supports Flink does at least suggest to me that in theory, it should it could work. Let me put it that way. But else, but this is like one thing to also keep in the back of your mind. I don't know for sure. I would imagine that if you're using Ibis, that then if you were using Polars, it would definitely be using the lazy API. But I could be wrong here. The one thing that I do think is fair to mention is that if you are able to solve everything with Polars, then Ibis might not be the package for you. Ibis makes a lot of sense when you've got different backends and you want to consolidate that. But if you're knee deep into polars and you're using some of its advanced features, it is also well possible that some of those advanced features are not available to you from Ibis. And that's also something to always keep in the back of your mind. So I definitely like the idea of Ibis because I may do work for a company at some point that has a BigQuery table and or some other backend technology that forces me to use SQL. And Ibis can be a reason for me to sort of emit SQL. That's super nice. But if the companies that I work with already use polars, then there's no need for me to introduce Ibis. And I might also worry that maybe I'm using a very specific polars plugin. Those might not be supported by Ibis either. It's kind of good to keep in the back of your mind. If you're interested in like some extra things, definitely check out the documentation because there's a bunch of features that I haven't really mentioned explicitly here. There are also some geospatial expressions, by the way, if that's your thing. Like some backends actually support some of this. But yeah, Ibis is cool. That's the main summary. Like, do think out loud if it's something that you definitely need. Partially because it might be better to double down on one backend. If you only have one, that's also kind of okay. And I also don't know about like adding scikit-learn predictions. Like if you want to update a table in your database, is Ibis the way to do that, or you want to maybe do that some other way? That's something I haven't really figured out yet. But yeah, that said, I do think Ibis it does solve a problem that is a real problem, and it's also a hard problem. So it's definitely cool that people are spending effort on it. Okay. Thanks everyone for listening. I guess like a final thing on my end, the Sample Space podcast is out. Like the first episode is actually out right now. If you're interested in learning more about how to make Jupyter a little bit more interactive with Jupyter widgets, there's a podcast of me interviewing Trevor Mance, the creator of AnyWidget. I thought it was a fun talk. Having said that, though, let's get back to work because it's past lunchtime at this point. And thanks for listening. Y'all have a good one.